Okay, now that we have that idea of this equivalent fractions, let's actually look at a definition here. How do we know two fractions are equivalent? Well, you may remember this kind of cross multiplication way. Two fractions are equivalent if, when we cross multiply, you could see A times D and B times C. If they're equal to each other, then we know that the two fractions are equal fractions if they're cross products. So it's the cross product process of determining that. That doesn't explain why that is. That's a deeper question of why that works, something I hope they'd be interested in, and even in class, or Googling or searching that, why that is. But it's a simple reason, which we'll hopefully get into a little bit. There's a theorem here: a fraction, A or B, is equivalent to another fraction when you multiply the numerator and denominator by that same number. So it's kind of like multiplying by 1. So hey, look at this right there and think about that before. So A over B is equal to A times N over B times N. All of this is going to allow us to do what we call simplify fractions in this next situation. But this first example is about checking equality. So one way is to cross multiply. What's 6 times 12? 14 times 9. Are they equal? They are. 126 equals 126. Another way would be to use the theorem, break up the numbers into factors, 2 times 3 over 2 times 7. So you could see, right? And then 9 over 21 is 3 times 3 over 3 times 7. So when we simplify that, we could see they're both 3/7. So they're both actually equal. They're equivalent fractions because they follow that form there. Now, what we'll remember when we simplify is 2 over 2 is considered 1. So another way to think about it. So anything times 1 is itself. So you could see some equivalence there. So we use the term simplify, or say 60 over 210 is simplified in simplified form when it's written as 2/7. And you can see the common factors 30 times 30. Sorry, 30 times 2 and 30 times 7. So the common factor is 30. So that's where we get 2/7. So 2/7 equals 2/7, which we know. So that's how we would simplify fractions, right? And so each of these has a different amount. I think sometimes students actually enjoy doing it because once they have their multiplications down, it's again a mental leap for them to see that 72 or 240 is 3 over 20. 9 over 32 is already simplified because there is no common factor, right? That we're multiplying the numerator and denominator by. And this one has 21. So pause to see if you want to look at that. But again, I think you probably have a good sense of that. But I think the most important thing is understanding that you could use the cross multiply approach, which we're going to use when the numbers are small and it's easy to compare, or we don't have any visuals, or this approach here is really essential here. And especially for you as future teachers, this is important in the sense of students doing algebra later. Now, that leads us to equivalent fractions, will lead us to ordering fractions. How do we know one fraction is bigger than another? Well, if you have time, go ahead and try this activity this is what we would do in class with those fraction strips that I told you about over here. And you can kind of compare when you look. I could see 1/3 is bigger than 1/4, which is bigger than 1/8, which is bigger than 1/9, right? When you compare the size, you could see that. And then the activity just kind of walks you through comparing other fractions, right? Especially this is fractions when the numerator is 1. How about when the denominator, sorry, when the denominator, numerators are when denominators are different, but when you have same numerators, different denominators, this nice little conceptual approach to thinking about that. Another way, it's like this one here, task 2, 5/8, 5/9, 5/10, 5/12, right? Which one's bigger? How would we know? It goes back to the size of the denominator. I know 1/8 is bigger than 1/9, so something to think about as we look at that. And then you play around, compare these, see which one's bigger by comparing the size there. All that leads us, though, of course, once we explore, to shortcuts, right? To ways to think about it in an efficient way. So how do I know if a fraction is less than another fraction? Well, if the denominator is the same, that's easy, right? If A is less than B, then we know A over C is less than B over C. That's easy when the denominators are the same. Harder ones are when the denominators are not the same. So we use the cross multiply, the cross product again. So you can see in these examples here, 7/8 and 9/11 cross products. 7 times 11 is 77. 8 times 9 is 72. So in that case, 7 times 11, we're cross producting A and D. So you could see since 77 is bigger than 72, we know 7/8 is bigger than 9/11. So that's what you're seeing here on these examples here. If it's easier, sometimes it's easier just to put them in common denominators, like on B, but look at 2/9 over 1463 over here. Oh, sorry. I think I have a typo here. Let's double check this real quick. 2/9 I know is because, oh yeah, we're multiplying. 2 times 36 is 72. 9 times 7 is 63. So there's just 72 and 63. So that's where we know 2/9 is bigger than 736. We could also multiply the 2/9. I'm going to multiply by 7. I get 14 over 63. Now I'm comparing 7. I multiply this one by 2, I get 14 over 72. Since they have the same numerators, 14s, and I know 163s are bigger than 172s, I know 14 over 63 is bigger than 14 over 72. Another way we could have done it, so you want to pause and look at that one. I know that one because 163 is bigger than 172. We learned that in comparing them, that if your numerator is smaller, like 1/3 is bigger than 1/10. So that's why we know that. Another way would have been to turn the 2/9 into multiplied by 4. So then you get that turns into 836. And then now you're comparing 836 using common denominator, 736. So again, we already know it's bigger, but that's a way to do it. And in this case here, 17 over 32 is greater than 19 over 40. We could cross multiply. I also can see that 17 over 32 is bigger than 16 over 32, which is a half. And then 19 over 40 is similar to 20 over 40, which is a half, but 19 over 40 is smaller than that. So that's another reason I know this is bigger than a half. This is smaller than a half, so this one has to be bigger. So something to keep in mind. And we're almost done here. I'll just finish this video. I apologize for the length. Try to keep them short. If you get a chance, play the video here from Howie Hua, our math educator here, as he explains some kind of compare fractions, some cool ways to compare fractions. And then he has this post he had posted before online, which fractions between 3/4 and 4/5. And so you could see here's 3/4 and 4/5. There has to be a fraction in between because there's space between there. You can see there's space. And there's a simple theorem we use. And it's here. Just add the numerators, add denominators, and you get another fraction that's in between. I have a cool little app here that tests you to see if you can find fractions between other fractions. So in this case, you could see 3/14 should be the answer, because 0 plus 3, 6 plus 8. So 3/14 is a fraction between those two. On a new one, what's between 2/4 and 4/3? I would say 4/7. I think that should work. Yeah, that's perfect. We could also do it other ways. There's more than one way to do it. You can see in the examples here. There's more than one, but adding them up. Another one would be, let's go ahead and take a look real quick. Another one, again, when we're comparing them, we add them. 9 plus 12 is 21. So these are ways to do that. Here's another way as we think about it. I turn in a common denominator. 7/11 is 14/22. 8/11 is 16 over 22. So when we think about it, what's in between that has to be 15 over 22, which comes from the formula too. So I want you to think about this also with common denominator approaches, like what's in between, 3/4 and 3/5. I want to finish this. Sorry, so long, but 3/4 is equal to, let's see, I'm going to multiply by 5. So that's 15/20. And then I know 4/5 is equal to times 4 is 16/20. And there's still nothing, right? I'm comparing 15. So I'm going to just get 30 over 40. I'm going to double that one. 32 out of 40. So now I know a fraction in between has to be 31 out of 40, something like that. The other way would have been just say 7/9 is another one. So because you do 3 plus 4 over 4 plus 5. So again, a lot of ways to think about it. This was a formula approach. Where was that at? Oh, down here. Or thinking with common denominators. We're done. 11 minutes too long.